I chose to read Dark Matter and the Dinosaurs by Lisa Randall for my nonfiction book project. Dark Matter and the Dinosaurs speculates the possibility of dark matter's influence in sending a meteoroid on a crash course for Earth. This book theorizes that during the Sun's passage through the midplane of the Milky Way, the solar system encountered a disk of dark matter that dislodged the distant object, thereby precipitating this cataclysmic event, the extinction of the dinosaurs. Now, before I get into the evidence of how dark matter caused the extinction of the dinosaurs, I'll first describe the pieces of evidence that prove the dinosaurs' extinction was indeed caused by a meteoroid. Three main things prove that a meteoroid caused the extinction of the dinosaurs: a dramatic change in the geologic record, the KPG layer, and the Chicxulub crater. The geologic record refers to all layers of rock strata, including fossils. When geologists looked at the geologic record and saw dinosaur fossils all of a sudden no longer present, it became clear that an extinction event had occurred. As well as this vital piece of evidence, the KPG layer was also another nail in the coffin for proving a meteoroid-induced extinction. In the geologic record, a layer of clay, ash, iridium, and other debris is present right around the same time dinosaur fossils stopped popping up, further evidence for a meteoroid impact. The last piece of evidence is the Chicxulub crater. Just off the Yucatan Peninsula, a large crater, the size viable for a worldwide mass extinction, can be noticed. Scaling 180 kilometers across, this impact easily could cause a mass extinction. Now, back to dark matter. Lisa Randall stumbles upon the proposed dark disk while trying to describe periodicity with meteoroid strikes on Earth. Periodicity is the proposed idea that meteoroid impacts occur on a specific timescale, like every 20 million years. After shaving the range of possibilities down, Lisa Randall felt that a proposed dark matter disk best helped to describe periodicity. She theorizes that when the solar system was in or close to the galactic plane, the distorting gravitational tidal effects of the disk, which lead to variocentric orbits of distant objects, acted on it most strongly. During these intervals, the thin, dense disk of dark matter disturbed the stable but weakly bound orbits of objects in the distant Oort cloud. This minor perturbation may have sent the icy body that caused the extinction of the dinosaurs towards the inner solar system, hurtling towards Earth. Randall speculates this event should occur every 32 million years, matching up perfectly with the time the dinosaurs went extinct. One passage from Dark Matter of the Dinosaurs I found significant is on page 272. It says, "But with dark matter, we have an even more airtight excuse not to have seen it. Dark matter doesn't emit or absorb light, which is, let's face it, essential for human vision. Dark matter interacts via gravity, but as far as we can tell, in no other discernible fashion." I find this passage significant for a few reasons. Our eyes, after all, can only observe visible wavelengths, so with dark matter not emitting or absorbing any light, it makes it physically impossible with current technology to view dark matter. However, I find it amazing and quite baffling that scientists can study and understand dark matter without even having the ability to see it. This passage truly shows the amount of advancement science has made. Dark Matter and the Dinosaurs relates to our curriculum in one specific way. A huge portion of this book focuses around past extinctions and the KPG extinction. This ties in perfectly with our curriculum. In class, we have learned about the major mass extinctions and have also investigated the extinction of the dinosaurs in more depth than any of the others. Reading through parts of Dark Matter and the Dinosaurs that have to do with the KPG extinction feel like review, thanks to what we learned in class. While reading Dark Matter and the Dinosaurs, I have learned so many things it is difficult to keep track of. I learned how craters form based on the size and velocity of a meteoroid, how scientists are currently trying to detect dark matter and what instruments they use, and many basic pieces of particle physics I previously hadn't known. I also have learned more about the Big Bang, many intriguing possibilities for what dark matter may truly be, and the differences between meteors, meteoroids, comets, and asteroids. Despite this seemingly in-depth list of now understood knowledge, this is only a handful of things I have learned while reading Dark Matter and the Dinosaurs. When it comes to recommendations, I must be brutally honest. I personally found this book a little slow-paced, and it often sidetracked at random points. However, the entire book was filled with lots of insightful facts and many intriguing scenarios. So, if I were to recommend this book to someone, it would be to a person who doesn't mind slower-paced books, is interested in physics and paleontology, and who is comfortable trying to read and understand high-level science. Thank you.